When you look at the world around you, everything feels obvious. The floor holds you up. The chair does not collapse. The walls do not melt into the ground. Matter seems solid, reliable, predictable. And because it feels so normal, we almost never stop to ask a very strange question. A question so simple that it sounds childish, and yet so deep that it quietly undermines everything we think we understand. Why doesn't matter collapse? Why doesn't everything around you, your phone, your body, the air, the planet itself, simply fall inward and disappear? This is not a poetic question. It is a technical one, and if you think about it carefully, common sense gives the wrong answer. In school, we are shown a picture of an atom, a neat little nucleus in the center, electrons moving around it like tiny planets around the sun. It looks harmless. It looks reasonable. We accept it and move on. But if that picture were truly correct, atoms could not exist for more than a fraction of a second. Because here's the problem no one stops to emphasize. Electrons are attracted to the nucleus, strongly attracted. If nothing prevented it, they should spiral inward, crash into the nucleus, and erase the atom instantly. Matter should collapse. Chemistry should fail. The universe should be very short-lived. And yet, here you are, sitting, breathing, thinking. So something is deeply wrong with the way we usually imagine atoms. To understand this, let's forget atoms for a moment and think about something familiar. Imagine a crowd of people standing in a small room. Some people push inward, trying to get closer. Others push outward, trying to make space. If everyone pushed inward with no resistance, the crowd would collapse into chaos. If everyone pushed outward, the crowd would dissolve. Stability only appears when opposing tendencies balance each other. Atoms work the same way. There is attraction pulling inward. But there must also be something resisting that pull, not a wall, not glue, not a hidden rod holding things apart. Something far stranger. Now here is where common sense fails. We like to imagine resistance as something physical, a spring, a solid surface, a force we can feel. But inside an atom, resistance does not come from something you can touch. It comes from the rules of reality itself. The universe has a rule that says you cannot perfectly pin down a particle. You cannot force it to sit still in a tiny spot without paying a price. And that price is energy. Try to confine an electron too tightly and it fights back. Not emotionally, not consciously, but mathematically, fundamentally. The tighter you squeeze, the more restless it becomes, the more energy it carries, the more it resists being trapped. So the atom settles into a compromise. The electron does not fall into the nucleus, but it does not escape either. It hovers in a fuzzy region, spread out, restless, neither collapsing nor fleeing. That restless balance is not a flaw in the universe. It is the reason the universe exists at all. Think about what that means. The solidity of the table in front of you is not because it is solid in the everyday sense. It is because the electrons in your hand and the electrons in the table refuse to occupy the same space. They resist, not politely, absolutely. Your hand stops not because it hits something hard, but because the universe says no further. Most people never hear this explained properly. They are given names, diagrams, labels, but not the idea. And the idea is far more astonishing than the picture. Atoms exist not because they are stable by nature, but because collapse is forbidden. This already tells us something unsettling about reality. The universe is not built on common sense. It is built on rules that feel strange, indirect, and deeply unintuitive. And yet, those rules produce everything we see. Now imagine for a moment that one of these rules were slightly different. Just slightly. Electrons would fall inward, atoms would vanish, molecules would never form, no water, no DNA, no stars, no life, no observers to ask questions in the first place. We are living inside a narrow window of possibility, and the window is held open not by force, but by restriction. That is the strange lesson atoms teach us. Existence is not guaranteed. It is negotiated. And as we go deeper, this lesson only becomes more unsettling and more beautiful. So let's go deeper now, but slowly, because this is the part where our intuition really starts to break. We already know there is attraction pulling electrons toward the nucleus. That part makes sense. Opposite charges attract. Even common sense agrees with that. If that were the only rule, atoms would collapse instantly, so clearly something else is happening, something subtle, something that doesn't announce itself loudly. Think about trying to squeeze air into a small box. At first, it's easy. Push a little and the air moves. Push more and it resists. Push even harder, and suddenly it becomes extremely difficult. The resistance grows as you try to confine it more tightly. Atoms behave in a strangely similar way, except the air is an electron and the resistance is not mechanical. It is built into reality itself. When you try to force an electron into a very small region, the universe demands a payment. That payment is energy. The tighter the confinement, the higher the energy cost. There is no way around it. You can't negotiate. You can't cheat. The rules simply say you may do this, but it will cost you dearly. So the electron refuses to sit quietly in the nucleus. It becomes energetic, it becomes restless, it spreads out, not because it wants to, but because it must. This is where people often misunderstand what an electron really is. We imagine it as a tiny ball, a little object flying around. But that picture fails badly here. An electron behaves less like a marble and more like a vibration, a blur, a cloud of possibilities. It does not have a sharp edge. It does not sit still. It exists in a state of almost here, almost there. And that fuzziness is not a mistake in our measurements. It is how reality works. Let's use another everyday picture. Imagine a child on a swing. If the swing is completely still, perfectly frozen, it takes effort to keep it that way. The moment you let go, it starts moving. Motion is natural. Perfect stillness costs effort. In the atomic world, perfect confinement is like perfect stillness. It demands energy. The universe resists it. So the electron settles into the lowest energy compromise it can find. Close enough to feel the attraction of the nucleus, but spread out enough to avoid the enormous energy cost of being trapped too tightly. That compromise is what we call an atom. Now notice something important. There is no little wall stopping the electron, no invisible shell, no physical barrier. The stability comes entirely from rules, not structures. The atom exists not because something is holding it together, but because the universe refuses to let it fall apart completely. This idea repeats itself again and again in nature. Think about traffic on a busy road. Every car wants to move forward, but there are rules, speed limits, distance between cars. You cannot occupy the same space as another vehicle. Those rules prevent chaos. They don't feel dramatic, but without them, motion would be impossible. Atomic rules work the same way. They quietly prevent collapse. Or think about a crowd at a concert. Everyone is drawn toward the stage, attraction, but no one can stand in exactly the same spot. As the crowd tightens, pressure builds. People push back. A stable pattern forms, not because anyone planned it, but because limits enforce order. Atoms are crowded places. Electrons are drawn inward, but the closer they get, the stronger the resistance becomes. Eventually, a balance forms. That balance is stable. That balance is matter, and this balance has consequences far beyond single atoms. When atoms come together to form molecules, the same rules apply. Electrons rearrange themselves, sharing space in a way that minimizes energy, not because they want to, but because the universe rewards that configuration. Chemistry is not a set of instructions, it is a set of negotiations. Even solids owe their rigidity to this. A solid feels hard because the electrons in its atoms resist being pushed closer together. When you press your hand against a table, you are N.O.T. touching the wood in a classical sense. You are encountering a wall of resistance created by electron clouds refusing to overlap. That is why the table does not collapse. That is why your hand does not pass through it. That is why the floor holds you up. All of it traces back to the same principle. Confinement costs energy, and the universe enforces that cost strictly. Now pause and think about how strange this is. Nothing is really solid. Nothing is really still. Everything is vibrating, shifting, balancing. And yet, the world appears calm, stable, reliable. This is where human intuition completely fails. We evolved to throw rocks and build shelters, not to understand probability clouds and forbidden collapses. So our brains insist on simple pictures, tiny planets, solid particles, clean boundaries, but reality refuses to cooperate. Reality is fuzzy. Reality is negotiated. Reality is balanced on a knife's edge between attraction and resistance. And the deeper you look, the more impressive this becomes, because this same logic applies at larger scales too. Stars shine because gravity pulls inward while pressure pushes outward. Too much gravity, and the star collapses. Too much pressure, and it blows apart. Stability again comes from balance, not dominance. Atoms taught the universe how to do this first. And once you see that, you begin to realize something profound. Existence is not automatic. It is conditional. It depends on rules that could have been different, but aren't. That realization is both humbling and exhilarating, because it means the universe is not simple. It is subtle. It is precise. It is astonishingly well-tuned, not in a mystical sense, in a deeply logical one. And it also means that common sense is a terrible guide to reality. Atoms exist precisely because reality refuses to behave the way we expect. And in the final part, this realization takes us somewhere even deeper, beyond atoms, beyond physics, and into the way we understand existence itself. As we reach this final stretch, I want you to slow down even more, because now we are no longer just talking about atoms. We are talking about what kind of universe we live in, and what it means to exist inside it. Everything we have discussed so far leads to a quiet but unsettling realization. Matter does not exist because it is strong. It exists because it is restricted. Atoms survive not because they are held together tightly, but because they are not allowed to collapse completely. Stability, at the deepest level, is not forceful. It is negotiated. That idea alone should make you uneasy in the best possible way. Think about how different this is from the way we usually imagine reality. We imagine foundations, supports, pillars. We imagine something solid holding everything up. But when you look closely, there is nothing holding atoms up at all. There is only balance, only rules, only limits. And those limits are not intuitive. Your intuition says that if something is attracted inward, it should fall inward. End of story. But the universe says, no, not so fast. The universe adds conditions, it adds costs, it adds resistance that is not physical in the ordinary sense, but mathematical, fundamental, unavoidable. This tells us something important about ourselves. Human intuition evolved in a world where objects are big, slow, and solid. We throw tones. We stack wood. We walk on ground. None of that prepares us to understand a world where particles are fuzzy, restless, and constrained by invisible rules. So when we try to apply common sense to atoms, we fail completely. And that failure is not a weakness of science. It is a lesson about humility. The universe does not care what feels reasonable to us. It operates on rules that work, not rules that comfort. Now let's zoom out for a moment. The same balance that keeps electrons from collapsing into nuclei also shapes the stars. A star exists because gravity pulls inward while internal pressure pushes outward. Too much gravity, and the star collapses. Too much pressure, and it explodes. The star survives only by balance. Planets form the same way. Galaxies form the same way. Even life operates this way. Every living cell is a balance between forces pulling apart and forces holding together. Too much order, and nothing changes. Too much chaos, and nothing survives. Life exists on the edge, just like atoms, and then there is consciousness, the most mysterious thing of all. Your thoughts, your memories, your awareness, all of it depends on atoms behaving exactly the way they do. Every nerve signal, every chemical reaction in your brain, every moment of awareness relies on electrons refusing to collapse. You are not just made of atoms, you are made of forbidden collapse. That realization should stop you for a moment, because it means your existence is not guaranteed by brute force. It is permitted by rules. Rules that could, in principle, have been different. Change those rules slightly and there would be no chemistry, no biology, no observers, no questions, no universe capable of wondering about itself. And yet here we are, not because the universe promised us anything, but because balance happened to be possible. This is where physics quietly turns into philosophy. Because once you understand that atoms exist only through balance and restriction, you begin to see a pattern everywhere. Progress, stability, meaning, none of them come from extremes. They come from tension, from limits, from opposing tendencies that never fully win. Even knowledge works this way. Too much certainty and curiosity dies. Too much doubt and understanding collapses. Wisdom lives in between. Feynman loved this idea, not because it was comfortable, but because it was honest. He was never interested in pretending that the universe made sense in a simple way. He was interested in the fact that it worked, even when it defied intuition. And atoms are the perfect example. They should not exist according to common sense. They should collapse. They should fail. And yet they don't, not because of magic, not because of intention, but because reality is deeper than instinct. So what do we do with this understanding? We do not walk away with a neat answer. There is no final sentence that wraps everything up. Even after all this, we still cannot answer the deepest question. Why are the rules the way they are? Why does the universe forbid collapse? Why does balance exist at all? Physics can describe the rules beautifully, but it cannot tell us why those rules exist instead of others. And maybe that is not a failure. Maybe that open space, that unanswered why, is exactly where wonder lives. The next time you touch a table, remember that it is not solid in the way it appears. The next time you feel the ground beneath your feet, remember that it is mostly empty space held together by rules you cannot see. The next time you feel small in the universe, remember that the same delicate balance that holds atoms together also holds you together. You are not separate from these laws. You are an expression of them. And perhaps the most beautiful thing about atoms is not that we understand them, but that they remind us how strange, fragile, and astonishing existence really is. Atoms exist not because it is common sense. They exist because common sense is wrong. And in that quiet contradiction, the universe reveals its deepest truth, not as certainty, but as an invitation to keep thinking, keep questioning, and keep wondering.